Yeah, no problem. Yes.
Avani is ready, we will start. Avani?
I'm ready. You can start.
Good morning to the respected professors, scientists, and participants. It's my pleasure to welcome you all to the 8th Technical Talk Series titled TransTech Talk Series, organized by National Transportation Planning and Research Center, NATPAC. Through this technical talk, we aim to provide a platform for the experts in the field of transportation engineering to share their knowledge and expertise with us. These talks will give us insights into the latest developments, emerging trends, and cutting-edge technologies in this field. I'd like to express my gratitude to all of you for joining us today. We have a truly exceptional speaker, Professor Sabya Mishra. He will be sharing his valuable insights with us on the topic optimal integration of on-demand transit services with fixed route transit network for cost-effective first and last mile connectivity. Before we begin, I'd like to invite Dr. Samson Matthew, Director, NATPAC, to deliver the welcome address. I welcome you, sir.
Thank you. Good morning to all, and good evening to Professor Sabya, as well as Mrs. Avani Arvind. We, NATPAC, National Transportation Planning and Research Center, working under the Kerala State Council for Science, Technology and Environment. In fact, NATPAC started the year 1976. Recently, on 12th of September 2023, our founder director, Dr. N.S. Srinivasan, departed from us, and he was the first director, and he developed NATPAC in such a way that it has achieved a nationwide recognition, and it is a very loss to the traffic engineering community, to the entire nation. He was a very senior, the technocrat, almost 90 years old, and our humble homage to Dr. N.S. Srinivasan. We celebrate National Engineers Day on 15th September, the birth anniversary of Mishra, the finest engineer in the country was seen. On this day, I wish you all a happy Engineers Day. Coming to the TransTech Talk Series, and today, this is the 8th talk in this series. We have started this TransTech Talk Series in the month of February 2023. And we arrange this talk every month. Normally, it will be on the second week of February, and normally it will be in the from 10 to 15th of every month. And this is the 8th talk in series. And today we have with us Professor Sabya Mishra from University of Memphis. Thank you, Sabya, for accepting our invitation and welcome you to this talk. Very sorry that we are disturbing you at a late night. I welcome Avani Arvind also to this talk. Welcome, Avani. And in fact, TransTech Talk series, we will arrange some foreign experts, but we wanted to our idea is to get the experience from the international experts, so that the research, the experience, so that we can extend that one to our research areas, as well as it will be useful for the nation. That is our idea. In a similar way, we have started another talk series, Transpedia Research Talk, the last month. Our idea is, again, giving an opportunity to the young research scholars, researchers who have just completed their PhD, and those who have done some different work in the country. we want to listen from them so that the other research scholars also will get that their experience or the new research topics. So I welcome all of you to this TransTech talk series. And normally we will get the participants not only from NATPAC scientists. We have around 25 scientists are with us and the project fellows. But in addition to that one, normally faculty and the students across the country from IITs, NITs, and the government engineering colleges, they used to attend this talk series, as well as some practicing engineers also there. So it is a good forum. I welcome all of you once again to NATPAC and to the TransTech talk series. Thank you.
So next, I'd like to invite Dr. Anla Cyril, Junior Scientist NATPAC, to introduce our esteemed speaker.
Good morning, all. Am I audible?
Yes. Yes, yes.
So, Professor Sabya Mishra is a professor in the Department of Civil Engineering at the University of Memphis. Before joining University of Memphis, he worked as Research Assistant Professor at the National Center for Smart Growth Research and Education, University of Maryland, College Park. He is involved with a number of national and state transportation projects from Federal Highway Administration, U.S. Department of Transportation, Maryland State Highway Administration, Maryland Department of Transportation, and Michigan Department of Transportation. His area of expertise include travel demand modeling, transportation planning and policy, econometric modeling, transportation economics, and finance. He is a member of Transportation Economics Committee and Freight Transportation Economics and Regulation Committee of the Transportation Research Board. We welcome you, sir, to the talk series.
All right, great. Good morning, everyone. Can you hear me okay?
Yes, yes, sir.
Okay, wonderful. So first of all, I would say that thank you so much for inviting us. It's a great opportunity for us to be here. We are humbled by that. What I will say is that the talk today will be presented by one of my PhD students. She is Avani Arvind. You can see her. So her video is on. So I will not take much time, but to mention about Avani, she was also a former NATPAC employee. And it's great that this is a connection that we have here today. So Avani will present the talks. I will just introduce the topic to everybody. We'll give a little bit of introduction to the topic, and then Avani will continue. And I will not be here for the entire talk. It's very late in the night. However, any question that I can answer, Avani also can answer. She knows this topic inside out, so she can answer. So I hope that you'll enjoy this talk today. So Avani, if you can go ahead and share your screen, and on the title slide, I will introduce this topic to the audience, and then you can take it over.
Yeah, sure.
Yeah, while Avani is sharing her screen, I would just say on this forum is that,
Dr. Mishra, can you see?
yeah, just make it full screen.
Okay.
So before I begin, I would also say, because I will not be here for the entire call, I would say that it's great to see so many people attending the call. So a big shout out to the organizers, first of all. I would say that in our lab, we always look for good students who are looking forward to pursuing their doctoral degree or master's degree, preferably doctoral degree. So if you come across an individual who is interested in pursuing a doctoral degree in transportation, please reach out to us. All right, so without much delay, let me introduce this topic to you. this topic is part of a funded research. So the topic came about as a concept from a state department of transportation where we live. So we live, our university is situated in a state in the United States called as the state of Tennessee. So Tennessee is a state that is home to, probably you might know, a company called as FedEx, who is the shipping and logistics company and one of the major companies in the world. So they're headquartered in our city. So Memphis is a city where we live. It's kind of is exactly at the center of the country. So overnight, we can reach out to many places in the United States and as well as parts of Europe too, just in overnight deliveries. So while the city that we live in the state is an urban area, there are many places which are very rural. And in the United States, there are cities which are not very well connected with transit. So in contrast to, for example, in a country like India, where we have extremely good transit connectivity and transit becomes a backbone of transportation, United States, more of United States, not every part, I would say, definitely suburban and rural areas are predominantly covered by single occupant vehicles. People have their own vehicles and they do travel. However, we know that there are captive riders everywhere. People do not have enough income to own a vehicle, as well as there are people who become old and cannot drive, and as well as people who are dependent, such as school-going children, and they really, if they don't have an option to ride, how do they go from their origin to destination? So for this purpose, our State Department of Transportation funded this study that look at areas where there is no fixed route transit that is available. Fixed route transit meaning thereby a regular bus service, going from one origin to destination, stopping at multiple places, having a schedule with frequency details throughout the day or for the entire month. So that is option one, what we call is a fixed route transit if available. Option two is one option called as demand response transit. So in the US, there is an option that is available because people need to be accessible. Accessibility should be given to individuals. So the demand response transit, the way it serves is that there is a number, like a helpline. So the user essentially calls the helpline to schedule a service, that I need a service to go from origin A to destination B. Can you please provide me a service? That service is available. It is very close to free of cost. And that is called as demand response transit. So the advantage of demand response transit is that service is guaranteed for anybody who wants it. However, that service is not if somebody wants to go now, because it is scheduled. So that is option number two. So option number one, again, is fixed route transit if available. Option number two is a demand response transit, which can be made, a trip can be made or reserved ahead of time for a later date based on availability. This is based on first come, first serve type of a service. The third is with advent of transportation network companies like TNCs, such as Uber, Lyft. Such type of services, even though they're very predominant in urban areas, not so relevant in rural areas. However, there is some presence. So the downside of this type of service is that it is not operated by public agency. It is not operated by government per se. It is operated by private agencies. And there is concept of surcharge too. That means based on a busy time, even though it is a rural area, the charge will be very high and everybody cannot afford it. So this topic is about, can we form an integrated system where public agencies, who are operating fixed route transit and demand response transit can collaborate with a transportation network company to provide a reliable service in the area so that every trip request that is being made can be fulfilled. So that is the goal. So Avani will explain in details, but it requires identifying every individual who is needing a service. What are their preferred destinations? When do they make that request? For what trip purpose? And can a direct trip be made with one of these modes, or a combination of modes are needed? If that is the cost, if that is the case, how much will it cost? So that requires some form of a simulation exercise to do so, to accomplish it. So which we did, and we provided from which area to which area, what type of service will be recommended, so that the agency who is operating there can take this recommendation and apply this service in their area. So this is a very, I would say, a practical study. So because this is part of a sponsored project that we did, we already finished the project. So, and we continue to work a little bit more on the academic side of it on this project, which Avani is going to explain more later, more now. So Avani, so I will be here for a couple of minutes, then I will jump off, but all to you.
Good morning, all. Can you hear me good?
Yes. Go ahead.
Yes.
Thank you, Dr. Mishra, for being here very late. I know it's very late. It was also part of my mistake. I missed the time. But anyways, thank you everybody from NATPAC for giving us this opportunity. And it's glad to be here again. Yeah, so I will directly go to the talk. Well, anyway, thank you again for inviting us, and especially from University of Memphis. Thank you from our lab. Okay, so this study, as Dr. Mishra explained, it was a project that is funded by Tennessee Department of Transportation to improve the public transit in the state of Tennessee. So our study, usually in Tennessee, there is a fixed transit. A fixed transit means the normal bus service that we have in India. So we have such kind of a system in Tennessee, in US, and especially in suburban regions, it's not very good, or not every people will use it, because people are more accustomed to using their own cars than taking a bus to traverse. But unlike cities like New York, where there is very good public transit services like subway, bus, everything, most of the major cities in US lack these things. So we want people to use more public transit than use their own personal cars, because we know what comes with using personal cars every day for every trip, because it is polluting and it is not environmental friendly. And yeah, and then it doesn't provide, like, because of a lack of public transit service as a whole, a lot of people who do not have access to a car lack accessibility to everything, especially hospitals, schools, everything. So in US, most of the city councils work for promoting public transit and make people use it. So to make people use it, we have to make it more accessible and comfortable to the users, where they could get as accessibility as they get in a car and as comfortable as they get in their own personal car. So we developed a model. So in this study, we developed a model where we could help the users, and also from the agency's perspective, agency in the sense the public agency's perspective, to make a good integration network. So in today's presentation, this is a major outline of today's presentation, where I will show the first slide shows the motivation and introduction and objective of the study, followed by methodology, results, conclusion, and acknowledgement. So the motivation of The study, as I said earlier, is first motivation is why multimodal transit. Multimodal transit means any transit service that is completed by using a combination or in a single way of using like a bus, a car that is like taxi services, bicycles. So mixing all these things in a single trip, or not even, you don't have to mix you don't have to combine them, you can just use them as such. But using multiple modes to complete a trip as a public transit way is called multimodal transit. So why such a service is necessary? Because first of all, it is enhancing accessibility and connectivity, which means I have to get out from my home and go to the place I need to go.
Hello, Avani. I think you lost your connection.
Looks like Avani got disconnected, or we really can't hear from her. Avani, can you hear us okay? Yes, Avani, can you speak again? We can hear you. Yes.
Hello. I'm sorry. I got power issues. I'm sorry.
Okay. All right. Go ahead.
Okay. Yeah. So we were talking about accessibility. So if I'm traveling from my home to the place I want to go, I need to have the service from my doorstep to the place where I want to go. So such kind of connectivity is not possible with the fixed transit alone, because they have specialized routes, and they are fixed route transit works in their own routes, and they have schedule to work on. So such a thing, so getting out from my home and taking an FRT is not always feasible. And maybe the distance that I have to walk to an FRT stop will be so long. So such kind of systems, such kind of things are not always possible. So what if I live in a very rural area and I don't have access to an FRT stop, but I have to travel very far and I cannot afford a complete on-demand transit like Uber? Then what is the solution to that? So a multimodal transit will give a solution to that by providing enhanced accessibility. The next thing is sustainable and environmental benefits, which of course, using our own personal cars for every trip is very expensive, not just for us, but it is environmentally very degrading, and thus creating a lot of external cost. And the fourth one is economic and social advantages, which means setting up a system of public transit, a big system of public transit, provides a lot of job opportunities to people. Such an opportunity does not exist if there is no public transit. So if you promote public model transit, then actually we are creating a large number of job opportunities too. So such a social and economic advantages also should be considered when considering multimodal transit. So in our study, as a part, what we did is we created an integrated system, which is actually combining two things. That is FRT, that is fixed route transit, plus on-demand transit. So what is the difference between the two? So FRT is actually, it works on a route, it has a schedule, and then it's not on my demand. Like it works on its own basis, depending upon the demand of the area. But on-demand transit like Uber or Lyft, it's like it's on my demand. Like I want an Uber, I book an Uber. So these two things can be combined. But there are so many things that should be considered when combining all these things. For example, from the consumer's perspective, only the FRT and only the FRT or anything that is operated by the government agency is affordable for me. But if I am always taking an Uber, it's not always affordable. Like, of course, Uber can be made affordable, but not always affordable. And from the agency's perspective, providing a very big fixed route system with routes and trips to everywhere is not possible. It's too much labor intensive. It's too much capital intensive. So such a system is also cost intensive from the agency side. And also environmentally, that we have already mentioned. So going forward, I will say FRT, which means fixed route transit, and then DRT means demand responsive transit, which is also an Uber or taxi kind of service, which is actually operated by government agencies in the US. So you can actually call the transit agency and book for a ride, or you can use the government agency's apps to book exactly like Uber or Lyft. As the only difference is that it is a little less costlier than Uber or Lyft. And then TNC is transportation network companies, which is also a private operated Uber kind of Lyft kind of taxi service. Yeah. So going forward, so the objective of our study is to propose a model for a multimodal integrated system that allows users to combine FRT, DRT, and TNC and determine the ideal leg sequence between origin and destination. And it also provides a decision support system to help stakeholders estimate the cost and benefits of integration. Yeah. So now we come to the methodology. So what is our aim is that for every OD pair, we have to find the correct leg sequence of mode, what mode to use. So when I say leg sequence, it means my trip can have a major chunk of the trip covered by some mode, and my first mile to that trip can be covered by another mode, and my last mile to that trip can also be covered by another mode. That means a trip can have a maximum of 3 legs and a maximum of 3 modes. And more than that is not viable at all. So we are not considering anything more than that. And so for every origin and destination, we create different scenarios. Scenarios in the sense how our modes are changing for each legs, that is a different scenario. So it is a combination of multiple modes and multiple legs. So with this, we create different scenarios to complete a trip. So this creation of scenarios is what we simulated in the study, and that is also an optimization problem because every scenario is created with optimizing the distance, like minimizing the distance for the trip. So in an integrated system, we have a fixed mode as FRT and on-demand mode as DRT and TNC. So Let's consider some characteristics of the each modes. For example, party, for the user, I have to pay very less fare. The bus charge is actually very less in US, and then it has a fixed schedule, and also since it has a fixed schedule, it operates in a very lower speed. And from the agency's perspective, operating cost per passenger mile is low. I'm not saying the operating cost of the bus is low, but per passenger mile it is very low. So it is actually good for the agency if more number of people are coming in. And then the external cost. Okay, external cost means the cost of all the other things, like how when we monetize the external factors like crash cost, pollution cost, noise pollution, all those things. So external cost per passenger is also very low. So it is actually a very sustainable mode of transportation. The next one is demand response transit, for which also the fare is low because it is operated by a public agency. But it's not that low as a fixed transit. And then the good thing is it is on demand, and also because it is on demand and it works like any car or any taxi service, it has a very good speed. And from the perspective of agency, it has very high operating cost because it is like providing a taxi service to a single person, not like running a full bus. And also similarly, the external cost is very high because it exactly works like a taxi service. And for the transportation network company, from the user perspective, it is high cost. It is very high cost, and it's good thing is it is on demand and it has good speed. And from the agency's perspective, since agencies are not directly involved in operating TNC, because TNC, Uber and Lyft are private companies, so agencies are not directly involved in it. But the thing is, if we want to have an integration of such a kind, usually public agencies collaborate with private agencies like Uber and Lyft to make a subsidized cost, for which the agency will bear some amount of cost and give it to the Uber and Lyft. So there will be the agency cost, the cost from the agency side is not zero. There is some cost borne by them, but that's not too high. And the external cost, obviously, it's very high per passenger mile. So with all these details in mind, we have to decide the combination that provide a minimum generalized system cost. So what is minimum generalized system cost? A generalized system cost is called the sum of the user cost, the agency cost, and the external cost. If all the sum is minimal from the combination of a scenario, then that scenario is preferred good. So our objective is to minimize that cost. So every trip minimizes the distance, and also above that objective, our objective is to minimize this cost. So generalized system cost is called the user cost plus agency cost plus external cost. If these three costs are minimalized, we consider that scenario good. Okay. Yeah. So for this creation of scenarios, we used agent-based simulation. And how did we simulate? What are the components of the simulation? Let's see. So the framework structure has three major components: the agents, the modes, the network, and ultimately finding the generalized system cost. So what does the agent do? The agent as such, the agent means the user. The agent is also me. So the user actually take a request from the OD metrics, because we have from the OD metrics, and I have certain values assigned with me because I have my value of time, I have my walking speed, and I know the time when I requested a trip, and I know how much I can wait for a trip. And if my waiting time goes beyond that, I will be restless, I won't take the trip. So the agent has a lot of characteristics like that. So all these characteristics are very important when we make the decision of creating scenarios. And about the modes, we already discussed the three modes that is available for the agent. And for the network, we have two networks. That is the FRT network and the local network. FRT network is, as shown in this figure, it's the second figure. It's actually a road system that is a part of the local or the major road system of that area. So there is a big road system in that area. And also, as a subset of it, we also have the FRT route network, where the FRTs are only within these routes, the FRT will move. It won't use the local network, but the DRT and TNC, they are cars, they can use any network, any road. It doesn't specify, it should not be specified to a single route. So these two are our routing areas. So we route our FRTs in the FRT network, and we route our DRT and TNC in the local route network. So this is our network, and from every OD, we complete, if possible, we complete every scenario, and then we calculate the generalized system cost. Yeah. Okay. Now scenarios depend. Okay. Then now my question is, how and what is scenario? So if you consider an origin and a destination as seen in the figure, each origin and destination have two big circles surrounding them. The inner circle is the walking buffer. That means anywhere within the inner circle, I can walk. I will walk. That is, in this study, we took it as 400 meters. It can be anything. It cannot be anything, but it can vary a little. But we took it as 400. And within this area, if there is an FRT stop, that means a bus stand, I can walk. I don't have a problem in walking. But if it is beyond that area, that's too much for me to, or the agent to, or the user to walk. So we should provide a first mile service to that FRT stop, which is larger than the walking distance. So the pink circle shows the accessibility buffer. The accessibility buffer is the area within which we can access an FRT stop. If the FRT stop is beyond the accessibility buffer, even providing first mile is not suitable in that case. Like, you cannot provide an accessible service there because it is too long for even a feeder service to work. So yeah, and then so for every origin and destination, we have these two buffers, the accessibility buffer and the walking buffer. So if my origin is here, I can have a leg 1 to the nearest FRT stop, and the leg 1, if it is longer than the walking distance, I will take a taxi or a DNC or a DRT, and then I will traverse through the FRT network to the stop nearest to my destination. So yeah, and I took the stop to nearest to my destination, and even then it's not, I don't have my last mile yet. So, and it is not in walkable distance. So what I do is I'll take again a DRT or TNC to finish my third leg. So this is a 3-leg scenario. But if I do not care about anything, all those things, I'll directly take a DRT. I can also directly take a DRT or TNC to my origin and destination without taking any legs. And so it is just a 1-leg complete on-demand scenario. And what if I'm lucky and I have an FRT stop within the walking buffer? That means I can take directly an FRT to the destination, where either I have to provide maybe a last mile if my destination is also not near the FRT, the walking buffer. So likewise, you can create multiple combination, and actually in the study we have 14 combinations. So there are, we introduced 4 integration strategies, that is FRT plus DRT, FRT plus TNC, FRT plus DRT plus TNC, and then just on demand and trip, that is DRT and TNC, either completely DRT, either completely TNC, or DRT plus TNC. And then we also introduced a new term called preferred integration strategy, which is the one in which the generalized system cost is the lowest, because for every scenario we calculate the cost, which is one of the important thing in this study. Yeah. So while we say about in the simulation, unlike we say, not every trip is feasible. So to make the trips feasible, or to check for the feasibility of every trip, we have introduced two major constraints. One is that if I could not find an FRT stop within the accessibility buffer, there is no point in giving a feeder service. Just take directly an on-demand transit, because you do not have to travel too much extra distance just to have an FRT in your trip. So just ignore it. And the second feasibility test is the trip distance, the FRT trip distance covered in a trip should be greater than the FRT coverage of that area. Which means if the area has a very good coverage, then most of our trip should be covered by FRT itself. If that's not the case, then there is no point in giving feeders. So the actual network of the area should be large enough to provide feeders. If it is too small, then providing feeders will not be as feasible as we think it will be. Yeah. So let's move on to the results. We have actually tried the results in two major network. One is a numerical example, which is called CS-Fault, which is actually a city in the US, but the network is studied multiple times because it's a very good network. So we have tried this in the CS-Fault network, and also we have a case study. So in the CS-Fault network, we created three fixed routes, and we have nodes, and then the FRT operates in we assumed that the FRT operates in a 30-minute interval from 6 a.m. to 6 p.m. with random demand. And we created demand randomly based on the area of each zone. So why did I come? So we also consider the income of the area. Why did we consider the income of the area? Because we assumed that user will give a value to the time that each scenario will take. So we assume that the value of time is based on the average income of each zone they are from. Yeah. So after the simulation, we have a total of if we have a total of 100% trips, we have with the demand that is created randomly, 7% of the trips could be directly walkable, like the origin and destination are within a certain walkable distance, and we gave them direct walking paths rather than any motor transit. And next, and out of the trips that is more than the walking distance, we have created multiple scenarios, and then 100% of the trips, that means all trips we assume can be completed by DRT. That SDRT means DRT alone, like the full trip origin and destination we provided with DRT. Likewise, 100% of the trips can be completed with DRT and TNC. So why are we combining all those things is because cost is the major factor. And then one important thing is with integration, we were 69% of the trips were able to be completed with providing feeder services to fixed route of the area. That is actually a very good number. But our aim in future should be to make this 69 also 100. Every trip should be provided with every trip should be completed with feeders utilizing the existing public transit network of the area. So this has this is completed by 3 different sub scenarios. That means the sub scenarios are based on which mode is chosen as what. Like if the first leg is completed by FRT or last leg, so or maybe first and last with something. So this is a distribution of how this integration is completed. So when coming to the generalized system cost, so that is our major study area. We can see from this figure, what we can see is that we have also created a hypothetical scenario called hypothetical scenario where we assumed that every origin and destination was provided with a bus service, which is actually not feasible at all in the real world, but we just assumed it just so that we can have a comparison with our original scenario, the scenarios that can be possible. As expected, the hypothetical scenario is the lowest cost scenario, like from every perspective, from agency, from external, from user, everything. It is the lowest cost scenario, but obviously it's not practical. But apart from that, we can see the integration scenarios are not that costly when compared to the hypothetical scenario, that it is not at a very high cost that is not even comparable. It is actually in a comparable cost range with hypothetical scenario, which is actually a very good thing to know. And we can see as the number of legs increase, as the number of modes increase, the cost tends to go high, which is also because of the transfer cost, the waiting time cost, because every transfer will have an extra waiting time, which adds up to the whole time of the people, making it not comfortable, not convenient. So all these factors add to the higher cost of the integration or multiple mode integration. So our aim is to minimize that. Yeah, but the good observation we got from is that the integrated scenarios, especially the two mode integration scenarios, are not in a very high cost range when compared to the hypothetical scenario. This is just for the case of CEO's fault. And now we have the state of Tennessee. So we took a city called Morristown from the state of Tennessee. So the Tennesseans usually use a single occupant vehicle to commute. You can see car everywhere. It's just cars. So according to the Bureau of Transportation Statistics, the commuters driving to work alone in Tennessee has increased from 68.2 to 83.1. That means 83.1% of the people use cars. It is just for the bare, not even 20% people the city is providing transit. But that 20% people also matters, and our aim is to make a mode shift from this 83.1. Yeah, and then for that, TDOT is Tennessee Department of Transportation have long range plans, a lot of long range plans, and they have a lot of TDM works going on. As a part of it, this is also such a work. Yeah, and so we are dealing with a city in Tennessee called Morristown, which is on the east. And this Morristown is not a very big city, but it is a city with fair population, and then it has 9 major zip codes, and it has an existing FRT route system. And also the Public Transit Agency has also recently introduced their DRT system. So everything is in place. Like there is a good DRT system, there is a good FRT system, and there is Uber and Lyft working there. That means there is good TNC system too. So this is a good place to have the study with. And the right side is an audiometrics of trips from each zip code to each zip code. Yeah, so when we use this network to analyze our model simulation, what we got is 73%, which is more than CEO's fault. 73% of the trips can be integrated with all the overcoming all the feasibility tests. So that's every trip out of 173 trips can be completed with integration in Morristown City, which is actually a good number. And then we have the cost factors for each of the trips, and you can see that the FRT has the lowest cost. That means $16.8 per user per trip. So when we think of 16.8 is very huge money, but it's not just the user paying money, it's also the money that is bared by the agency, and also that is considering the external cost and all these things. So it is actually a fair amount, but the on-demand services takes a lot of money. That is $49.3 per user per trip. That's huge money for a single trip. But yet, the final outcome of the study is that before such an integration ever existed, if there was only FRT in that area, only 0.04% of the area of the trips were accessible. The captive riders, exactly 0.04% of their demand is met, which is actually very low in number, and that demand can be increased to 73% if integration is done, which is actually a huge jump from 0.04 to 73%. And this is actually happening in that city. So, yeah. So the viable possibility of integration is 73% of trips, and only 0.04% of the existing trips have direct access to FRT stop, but integration enhanced their accessibility to 73% of trips. Yeah. And yeah, this is the final showcase of our output. That is that where we have the audiometrics, and we will provide the preferred integration scenario. So you can see the green cells. The green cell shows that there is an FRT network in that cell area. And whenever there is an FRT network, people prefer to use transit. But in the yellow cells, there is actually no transit service, the bus service available. So they only can use whatever on demand is available. So what we got from this inference we get from this study is that there should be an FRT route in all the cells. Because if there is an, but it's not always feasible, but at least to cover major areas, we need to provide FRT service in a lot of areas. So not just integration can provide better coverage, but also making the the bus service a bigger in area to create a more preferable integration strategy. So this could be a good output for agencies to know, like which place needs more service. So this can be a result that can be used by agencies to look at which place or where to provide more service. Yeah. So yeah, the conclusion of our trip is for our study is that first mile, last mile is the biggest problem for people not using transit service. So we have provided a solution of how to create, because our simulation provides you the preferred or the best strategy with the lowest cost and the least distance traveled. And with our simulation, we created 69%. We could show that 69% of trips in Searsfall and network and 73% of trips in Morristown could be integrated with the FRT network. And when we are saying all the trips, we also considered the viability test in terms of network coverage and cost. So that means the 69 and 73 number come up after covering all the viability test. And yeah, so the limitations of our study is that we assumed that all services are available and they follow the schedule and route. So which cannot be not always the case in the live settings, but yeah, and then there is the good cooperation with TNCA and the government agency, which is not from our side, which is the agency side part. Yeah, but we assume that there is good cooperation with TNCA and agency. Yeah. Yes, and this study is funded by Transportation Tennessee DOT and CTIR in University of Memphis. Thank you. So this is what I have to say about the study. Please go forward with the questions. I'm pleased to answer everything.
Thank you, Avani. The floor is open for questions.
This is Anish from NATPAC, from the Ernakulam Regional Center. So, thank you for the good presentation. But as you were rightly saying, from the last 20 years or so, people have been using their personalized trips. So, what do you think are the strategies that can be adopted so that that habit can be reduced and people can switch over to public transport? Is there something that has been taken into account so that people who have been using their personalized transport can switch over to public transport?
Yeah. Should I answer or Dr. Mishra is here?
Yeah, if Dr. Mishra is there, please, sir.
Okay.
Yes.
I'll answer.
Yes. Avani, first of all, you presented very nicely. I was thinking to drop off sometime, but during the call, but you made it nice. Great job. So to answer your question, the question is a very relevant one. Let me give you a little bit of statistics so that kind of you get a sense. So if we take United States as a country, let me put a question back to you. Don't worry about if you give wrong answer. It's all fine. For every vehicle, how many parking spots are available? If we make that ratio in the United States, what number will that be? Like, do a guess. That means if you own a car and you go to a place, how many parking spaces would be available? For example, in India, if we go to a mall with our own vehicle, there may be a challenge in terms of parking, or there may be something like 1:1 ratio of parking spaces will be available. If we say that again.
No, we don't know the right amount, but then it's the parking is a major issue.
Not major issue. It's plentifully available. For every car, there is minimum 10 to 11 spaces are available.
Okay.
That means automotive industry is so affluent because without private cars, it's very challenging because think of United States as a country with the vast amount of area that it has and the sprawl nature of living, like people live far out from the urban areas or downtowns. So if public transit will be provided, then we see that in many cities, most of the buses operate at very low capacity. That means capacity, low demand, I would say. Capacity is there, but with very low demand. That means if there is nobody riding buses, then we are spending a lot of taxpayers' money in a mode that is not being chosen. So if someone is owning a vehicle and going to a place, and there are on an average, I'm saying this number on an average in the entire country, there are 10 spaces available. That means there is no incentive for people to switch modes. Parking is plentifully available. Fuel that is being used is also something that is one can afford. So there is no challenge essentially to shift. So to answer your question, there is a stronger push nationwide. So Avani mentioned during her presentation in one of the slides, she used a term called as TDM. So that has been referred as travel demand management strategies. So we do have an ongoing project that we're working on. So the goal of that project is essentially to find strategies how we can motivate users to use public transit, not penalize them, but to nudge them. Nudging meaning thereby, we're not incentivizing them for anything, but we are somehow mentally preparing them that what are the benefits of using public transit. So how people can use public transit. So as Avni was showing in her presentation, and we have other projects ongoing on that, many of the US cities are slowly getting rid of fixed route transit because it's not viable. However, they're replacing fixed route transit with not demand response, but what we call as mobility on demand services. Mobility on demand services, meaning thereby the way we use Uber and Lyft, in the similar way, public transit agencies and also can have multiple vehicles waiting in catchment areas where there will be a need, and they will pick up and drop off, not from origin to destination directly, but from origin to a nearby fixed route stop. So fixed route will operate, but mostly on the city core. In the peripheries of suburban areas, mobility on demand or on-demand transit will operate. So this integration of on-demand transit with fixed route transit appears to be plausible now. So is this a one solution that's going to fit for all cities? Not necessarily, but this is what we are seeing in few of the cities that we are working with now. So where the bus doesn't need to operate empty, we do not have to pay the operation and maintenance cost of a bus when it's not properly utilized. Rather, we can go with low-cost solutions of operating smaller vehicles. Drivers also do not need to there will be more drivers needed, but they do not need to be all-time or full-time employees. They can work based on their preferences of number of hours or agency's preference. So that model seems to work well. On-demand transit integrated with fixed route, so that supply side is given. Demand side, how many people will use? That is a concept of nudging is what is being used. But I can tell you that it's not that easy to motivate individuals to leave their private vehicles. So it's going to take a lot of time, sometimes in multiple decades, to arrive at that point where we see that a lot of people use public transit. Sorry, I think I took a lot of time to answer one question, but wanted to give you some context.
Thank you, sir. Two more points to add. One is that what are the components that were considered for the external cost? Can you shed some light on that? And also, electric sort of vehicles, were they also taken into consideration, or these were the gas vehicles?
For external cost, we actually considered two major variables, that is the crash cost and the monetized cost of pollution, and then also all these data we got, and then the insurance cost details. So I just remember these three major variables that I considered, but I have to look into it to give the exact number of variables that I have considered to calculate the external cost. It actually has a lot of variables, which is actually coming in the broad spectrum of these three. Well, I did not get the second question though.
Electric vehicles, were they considered?
Not in this study. In this study, we assumed it as not electric.
Okay. Thank you.
Hello, everyone. Can you hear?
Yeah.
This is Sri Kumar from NIT Surathkal.
Yeah.
First of all, thank you for the interesting presentation. So this question is just an extension to what our Anish has asked. So can you throw some light on the optimization formulation you have used, minimizing the generalized cost? I believe some formulation has been used. So the nature of that problem.
Actually, it's the optimization is not minimizing the generalized cost. The optimization happened in every scenario with because our vehicles are traversing in routes that we created as graphs. So we assumed that every mode of vehicle will choose the shortest path for them. If it is an FRT, there is no shortest path. It is they have to use the scheduled route. Other than that, for DRT and TNC, we use the shortest path. And then we estimate the generalized system cost. And out of the generalized system cost, with the minimum generalized system cost, we took it as the preferred scenario. There is no optimization for the system cost. We just optimize the distance.
So what I understand is that is a scenario analysis basically, not.
Yeah.
Okay, thank you. So, but there is a scope for extending into an optimization formulation as well, right?
Of course, there is scope for optimization, but all these scenarios are optimized in terms of so the cost function is distance.
Okay, thank you.
Hello, I'm Dr. Vasudevan from NATPAC. Yeah, I have a few small queries. First of all, thank you for this wonderful presentation. Actually, in this analysis, did you consider any willingness to shift kind of values for this, or how you train these agents to travel from one place to other? And secondly, you were talking about DRT, right? Demand responsive transit. So whether actually this is what I guess is this is based on the demand and it is scheduled for later time, right? It may not be at the present time. So if it is scheduled for later, whether it is considered as a feeder to public transport or it is directly from the origin to the destination, like Uber Lyft. Thank you.
So usually the DRT system in US can work as both. Like we can already schedule the trip and also we can ask for it on demand. So in very big cities, like, so where I am in Memphis, we can schedule it on demand. Like I can ask for an on DRT service just now using the app. So it works just like on how we book Uber. So in this study, we assumed it just like how it worked in Memphis, like it is available on demand. And it is actually available on demand, but usually so DRT is not a new service. DRT was existing from 80s and 70s. So at that time, people used to phone and tell like to come and pick at some point of time. So now it changed from phone to apps, and just like how Uber works. And I forgot the first question.
Yeah, actually, it was related to the willingness to use public transport, whether that was considered in the analysis or how you train the agents to move from one place to another.
So in this study, the willingness of the people are not studied, but we assumed since we assumed all the agents as captive riders and they have to use public transit rather than they have a choice of. But they have a choice of not using it, but they will prefer to use it. That's what we train the agents to do. Use a system when it is available. That's how our agents are trained. Like if available public transit, then we train them to take it.
Okay, but in that statistics, as you said, it is almost more than 80% of the people are using their personalized modes. So, and rest of them are already it's captive, right? So you are assuming that all 100% are captive in this case. Is correct?
We are assuming our demand. We don't assume it as captive, but because since we are promoting a public transit in this study, we assume that people try to take a public transit. So we assume the agents will try to take a public transit because they don't have a car. They are captive. They don't have the car available. They only have the public transit scenarios available. Yeah.
Avni, maybe I'll add. So it's a good question. Maybe we were not clear while we were explaining it. So what we did was that we took records of individuals who use public transit traditionally.
Okay.
So that is based on demand response survey records, demand response data records, whoever made a call, people who use the buses also in the city, and whoever has used also TNC. So we just simulated that demand only. If your question is that there is a preference and competitiveness and willingness to pay to use a specific mode, that competitiveness we did not analyze here. That can be a good extension to this study. However, here, those individuals, whoever in the past have used public transit, or what Avni was telling that they were captive riders, they were only simulated, assuming that they will continue to use public transit, which is a reasonable assumption. So that's what we used.
Understood. Thank you, sir.
Thank
All
you,
right.
Dr. Mishra.
Hi, can I ask a question? It is okay. Hi, yeah, my name is Vijit, and Avani and Dr. Mishra, wonderful presentation. And it's really good to see, there is a lot of research happening on on-demand mobility. My question is this, on-demand. So did you consider shared rides, or was it for individuals? Did you consider bunching of rides into one vehicle, or was each person given an individual vehicle for this purpose?
Avani, you
Thank
want to
you
go?
for the question. There is no sharing here. That's a very good future research. We actually are trying to expand this research in that direction to share, for the vehicles to be shared. But right now we assumed it is individual.
Yeah. The reason I asked is because I have worked with VIA. I have implemented on-demand ride sharing. You must be aware of VIA technology.
Yeah. Memphis has VIA.
Yes. So yeah, that's why I asked, whether you are sharing the rides. I work in Doha Metro in Qatar, and have implemented, on-demand ride sharing. So yeah, that's my background. And if I may just take the question from one of the previous ones, the public transport ride percentages. I think we are past a stage where we can attract people with incentive. We have to actually disincentivize people to use private cars, and especially in India and all, where the private car numbers are increasing. Your push factors are what is going to help, and not the pull factors. The pull factors, you have provided a good quality transit. Everyone has a good quality transit, but you need to have push factors, TDM measures. Instead of minimum number of parking, go for maximum number of parking. In a building, you should only have this many parkings. That's it. That's the only way you can get people to use transit nowadays. Okay. Thank you, guys, but wonderful presentation.
Yeah, good points. Exactly, yes. So that's what is happening right now with various TDM measures. The goal is to limit the parking spaces for new facilities, those are upcoming.
Yes.
And also change the existing parking structures, especially in downtown areas, so that when individuals are coming to downtown, it's not about 1:10 ratio. That's not how it's going to work. So that is how the legislation is moving. But as
there will be a lot of pressure from the car lobby, because especially to push a TOD type development with maximum parking restrictions, I'm sure you'll face a lot of issues in that.
Yeah. So to give you a bit of context here, like we're in a city where we're promoting public transit, but at the same time, Ford company, they're building their largest electric vehicle truck plant. Truck meaning thereby not the tractor trailer in the US, the pickup trucks, which are like a little bit bigger than sedan. So
the Rams and the Raptors,
yeah, like Ford F-150, which is very famous. So while they're selecting this area to be their manufacturing plant, that's already an incentive for an automotive company to come. So this debate of limiting parking spaces and penalizing, unless we're in a city like Singapore, where space is already a constraint, and the only way to move is to do this constraint type of scenarios. When space is affluent, that is a challenge. That's what I was referring, is that it's going to take time in its way. Where there is a realization, when the realization comes that yes, it's time for us as a community really to move to public transit. So then, like principles of nudging might work. So yeah, those are few options. It's not like one size fits all type of a problem. We need to look at various types of strategies, but you mentioned some nice ones.
Okay. All right, guys. Good luck with your research and hope to see the ride sharing also soon. Thank you.
Yeah, thank you. Yes.
This is Shashikant from Hyderabad. So it's been a long time to look after transportation concepts. So Dr. Sabya and Avani, it's a nice presentation. And I mean, now here in India, we are observing, work from home based lifestyle right now. So with this and with the pandemic also, one side, number of trips have come down because people are able to work from home. But on the other side, because of the pandemic, people are not encouraged to use the public transportation. So they're buying cars, and that way it's increasing. So this pandemic thing and work from home thing, these two parameters, how sensitive our methodology or our model, and if because from now onwards, whether still if COVID is in control, right? But people have some kind of fear factor to use the public transportation unless there is a challenge with respect to their income and other factors, right? So if these have to be considered, these parameters, so do we have the flexibility to consider those, and accordingly what kind of outcomes can come? This is my first thing, just observation. Second thing is, if the same concept has to be like checked in Indian conditions, right? So what is the specific area and how it can help our Indian traffic condition scenario?
Yes. Shashi, please switch on your video. I haven't seen you for ages. It's good to hear from you. Okay, all right.
Thank
So
you.
Sashi's question is a very heavily loaded question. Okay, we can't answer those questions just like that, especially the first one. The first one is, okay, good to see you. The first question is that, see, we're not doing any demand estimation. Your question is a good one. Our question is more like an operational question. So operational question meaning thereby we are given a system in place such as number of vehicles needed, number of individuals needing service. All we are doing in this process is transporting them from point A to point B, making sure that can they move by one mode or combination of modes in this case, and what is more effective. That's what we're doing. Your question is a good one, is that now scenario is changing. People have preferences of whether to go to work or work from home, so on and so forth. So if those are questions, then we got to completely revolutionize, completely change the scope of this study, such as collect data, collect preferences of individuals, what they want to do, so on and so forth, find demand to begin with. We did not estimate demand. In this study, demand was given to us as is. All right, so that's the first question. The second question you asked, please say that again, I forgot.
Yeah. So, if this concept, if this methodology has to be verified for Indian traffic conditions, which are the areas and what are the outcomes that we can expect?
Yes. So the good question. So I would say that the approach can be used anywhere. That's absolutely not a problem. However, we applied our approach to a very small city, not an extremely large city. For example, if we say we will take our approach and apply in Mumbai, for example, we don't know whether our approach is going to, how many days will it take to solve the simulation approach in a city, such a mega city like Mumbai, for example, or any metro areas. What we did and what is feasible and which is solvable in due time, something in expected reasonable time with appropriate accuracy of what we did, worked on something what we refer in the US is like tier 2 and 3 cities. So tier 1 cities are, you need to have minimum 100 or more number of vehicles, buses. You need to have some form of light rail, so on and so forth. So those are tier 1 cities. We did not test this in tier 1 cities. We tested this in a tier 2 or tier 3 type of a city. So if you want to take our approach and apply it to anywhere in Indian context, so a similar type of city, if you see, which are not heavily urbanized, you can apply our work as is. So this work also can be applied to larger cities. It is just that we're not very sure about computational time because we did not test those ourselves.
Thank you. Thank you, Sabya. Thank you, Avani.
Okay.
I wish you all the very best.
Thank you, Sashi. Yes. Any more questions? Yes, it's wonderful. All great questions. Yes, please go ahead.
There is one question from Sanjay NATPAC. Is there a minimum trip length to be traveled through FRT? Chances of trip makers not to proceed with TNC in those scenarios? Since the chat box.
Yeah. We saw that. So there is a trade-off. It is up to the user really to set those. So the minimum trip length typically is that out of 100% of your trip length, if you are traveling, say, less than 30% in any of the modes, then you will think twice. Why should I do that? Right? Why should I choose a specific mode if it is less than 30%? Rather, you kind of try to use something such as a non-motorized transport to begin with. Maybe bike to a place, if you can bike, or walk, if it is that. So I would say that is up to the user really to set it depending on the area so that it becomes feasible. So I would say the number should not be in a magnitude, but somewhat in a percentage. I don't recall what we did use in our study. However, from the total trip length, a percentage can be attributed to kind of shift between modes, and that should be fine.
Thank you so much. Sabya sir.
Fine. Okay. Thank you, Sabya, and as well as Avani. I have three the comments on this one. First one is Avani, why there is only you have restrictions to 3 modes? You have any any and probably less the system which you are considering may have can permit only 3. Some other listener participants also mentioned probably in Indian conditions you may have to consider more how we can convert your the concept into to Indian environment. One thing. Second point is our Anish he is working on origin destination metrics for the state of Kerala, not to a small city or to any single city, but as all of you know, we consider the Kerala as a single city. Maybe most of the cases, the area is considered to be a urban or semi-urban case. So we wanted to take Kerala as a state as a single city, and we wanted to integrate the system, maybe the long distance and other. Probably Avani was also knowing that when he was there with me during the beginning of the KSCSTE problem. Still, that problem is existing. So how we can do that one? Because he's working on the origin destination metrics with the support of Professor Tom and Baudran from IIT Palgada, and we wanted to develop that one for the entire state. So that is second. Third one is we are working at Ernakulam. Of course, our regional office they are working. Vasudevan is also Vasudevan and Water Metro. Like a part also we are considering. There we have that multimodal integration concept is there, and it is partially introduced, not okay, in concept, like it is introduced, but like it is not fully functional. In that case, how we can, there we have the metro is there, city services are there, we have auto rickshaws are there, even people are using, some people are using cycles, then even the like a pedestrian, the pedestrian concepts is also there. How to integrate that one and how we can do that one. Maybe a similar concept is there at Trivandrum city, where we have the city circular, the government KSRTC support circular services are there, where we wanted to introduce the feeder services. So then, we wanted to shift the entire private uses, the trip makers into a public transport mode. So how we can extend, of course, it is not I am not expecting an immediate answer for that, but probably Avani and Professor Sabya can help us so that our people can work in that direction. Second question. And final question, there are good number of project fellows are attending this the talk. Probably, Avani, what is that your advice to the project fellows and to the research scholars, how you can how they can develop their career, or how can you, probably you are the right person to advise them. Thank you.
Thank you, sir. Thank you so much. Nice to see you again. I believe that Kerala has existing, especially Kochi. I have read a paper not very recently. It's a 2020 paper. I don't remember the title of the paper, but the paper was exactly about the multimodal transit system in Kochi. Kochi, that means Ernakulam. It was before the water metro, so it was integrating the Kochi metro, and there was the metro card, and with the metro card you can not just use the Kochi metro, but you can use multiple services. I'm not sure about it, but I read it like 2-3 like long back, but there is actually a multimodal transit system card. It's available right now in Kochi, and which actually uses Kochi metro, and maybe it might have expanded to using water metro also. And in Thiruvananthapuram also, I don't know if there is a multi-modal transit card like in Kochi, but Trivandrum also has great potential to be in that it's a good ground for integrated system, because it has a lot of the public transit is so good in Trivandrum, and then we can provide a lot of good feeder service. Actually, Kerala, I don't know about the rest of India. Mumbai will be very difficult, but Kerala is a very good ground for integration. That's what I believe. And Dr. Mishra, do you want to say something?
I think the question was, I remember the first question and I will answer that, but I think there was a question for you, the last question. That is
Yeah.
directed towards you, and you should answer that. So
Only Avani can answer that.
I don't know. I was constantly trying for PhD from my master's, so my goal was set to do my PhD right from my second year of master's. So I don't know. I was constantly keeping on updating my profile, and I messaged Dr. Mishra, like I read his entire profile, his entire papers, and I mailed him, Dr. Mishra, I'm so interested to do PhD with you. So likewise, study your professor, study his papers, look whether it is interesting. If you like the person and his work, don't hesitate, just mail.
Great, Avani.
I don't hesitate with anybody. I just mail. And Dr. Mishra was kind enough to read my mail and reply to me. Yeah, that's what I say.
Good. Yeah.
I'm so glad that he replied there, because usually mails go unread, and nobody, like big professors like him, usually have the tendency to not read mail from unknown people, and it could have gone as a spam mail, but he replied, yeah. So, and thank you for hiring me, Dr. Mishra.
What are you talking about? It's great to have you. So it's opposite. So I would just add something there. I can tell that Avani knows this. We have more work than number of people. That's most of the time that is the case. So if anybody is interested, all we are looking for is motivated candidates. If somebody is interested to pursue where there is a passion and wants interest to pursue doctoral studies, definitely email. And I try to respond to relevant emails, but I'm sure that if I don't respond, then please bug or through anybody, any channels, just reach out. But I'm sure that any email that comes from at least with relevant details of a resume and mentioning specific interest, definitely we'll do that, and then we'll go over it, and then we talk to individuals who are interested just to make sure that they're interested. Then we support in every way possible to bring them on board. So that's what I began my introduction in the very beginning, is that we are looking for motivated candidates for doctoral programs. So if anybody's interested who are attending the webinar today, as well as those who are not attending, might be listening to the webinar later, or anybody in your contact, yeah, please do encourage them to apply to our program or contact us, and then we'll be in touch. I think that's it. I think I will answer your first question that I remember. I think Avani did answer the other questions. Your first question was that why did we consider 3 modes? That's a very good question. So there are so many other modes being available today. So the answer to your question is that, yeah, why not? Definitely can be done. Where we did the study, where we used the study area as a case study, in that area, any other type of mode is not feasible because it is very close to, you might have heard, or if you have not, you can Google. Tennessee is also famous for something called as Smoky Mountains. Smoky Mountains this city is almost very closer to Smoky Mountains in the Appalachian region, which crosses so many states, such as Tennessee, Virginia, North Carolina, South Carolina. It goes all the way through the Appalachian region, just one mountain, humongous. So this is one of the cities closer to that. So the terrain, the number of individuals who live there, it was not a very urban area to begin with. So in our case study, we did not use other modes which were not feasible to that region. However, we can take our approach and insert any number of modes as well to this framework, and it should work with a little bit of tweaking. So the approach should work, what we have done. It's just that in our case study, we used only 3 modes. Another mode or another 2 or another 3 modes, they can be added without any problem. But great questions, a lot of questions. Too many things can be done. Avani will only do that much what she can do in her PhD. I'm sure many other things also will remain, so those will be done by others. We will not pressurize Avani to do everything. As much as whatever she can do in her time frame, whatever she likes, we'll do that. And then other things will be done by subsequent students.
Great, Professor Mishra, and good Avani to listen. And I think this is the longest tech talk we had, because a lot of questions, a lot of interactions. And we allow I'm sure that it will go for another 30 minutes. I'm sure that it is very late for you to, so better probably we'll close that. And those who wanted to interact more, probably we can, through mail probably we can communicate. Good luck, Avani, good luck to best wishes to Professor Mishra. Over to Shahid.
Thank you, Professor Sabya Mishra and Avani Aravind, for a valuable insight on this topic. Now, I'd like to invite Dr. Praveen, Junior Scientist, NATPAC, to deliver the vote of thanks for today's enlightening session.
Good morning, everyone. On behalf of KSCSTE-NATPAC, I would like to extend my heartfelt gratitude to each one of you for joining us today for this insightful technical talk on the topic, Integration of On-Demand Mobility with Fixed Route Transit, a Cost Analysis. It has been an enlightening and thought-provoking session, shedding light on the advantages of integrating fixed route transit and demand response transit so that every trip can be fulfilled, thereby boosting mobility and user experience. First and foremost, I would like to express my sincere thanks to our esteemed speakers, Dr. Sabya Mishra and Ms. Avani Aravind, whose expertise and knowledge have truly captivated our audience. Thank you, sir, and thank you, ma'am, for delivering an engaging and informative presentation backed by thorough research and practical insights. We are grateful for the knowledge and insight you have shared with us today. I'd also like to thank all the attendees who have joined us today and blessed us with their presence in making this a successful event. The questions and discussions that followed the talk showcased your deep interest in the subject matter, and I commend your engagement. We are very much thankful to Director NATPAC for his constant guidance and support in shaping this wonderful event. Finally, I would like to thank our division heads and the organizing team for their meticulous planning and coordination that made the smooth execution of this program. In conclusion, I believe we have all gained valuable insights from today's technical talk, deepening our understanding on growing demand for integrated and shared mobility services. Thank you once again to everyone involved, and we look forward to hosting more technical talk in this series and continuing this legacy. Thank you all.
Thank you, Dr. Sabya Mishra, and thank you, Avani Aravind. Sir, can we close this?
Thanks for having us. Yes. Have a great day.
Thank you for having us. Have a great day.
Bye.
Thank you.
Good night to you people. Good night.
Good night. Thanks.
Bye.
Thank you. Thank you, everyone.